Okay, in number 15, we're dealing with an advertising situation. The table shows the cost in millions of dollars of a 30-second Super Bowl ad on TV as a function of the time in years since 1997. So what does that mean? Years since 1997. Well, if I'm 0 years since 1997, that would be like 1997. If I'm 1 year since 1997, that would be like 1998. Or if I picked maybe 5 years from 1997, that would be 2002. In 2002, 30-second Super Bowl ad cost $1.9 million. We are supposed to graph the function. So whenever we graph, one of the first things we have to decide is how we're going to make our graph. What are we going to pick for our scales on the x and y axis? Now, I'm not going to delve too much into the negative side of things because we don't have any negative values. So I'm going to keep positive values and mostly positive values for my x and y axis. But I'm not going to call it the x and y axis in these cases because we're not dealing with x and y variables. In this case, we've got t, our years since 1997, and c, our cost in millions. The cost depends on the year, so cost is our dependent variable, which we usually associate with the y-axis. So I'm going to call this cost. I'm going to call this t, time since 1997. We should always describe what's going on in a real-world situation, maybe with a little better writing than I did there. I'll try it again. So I've got years since 1997, and here I'll call it money in millions. Now notice our x values or our t values go from 0 to 7. No problem fitting that on the graph. I've got plenty of boxes. But our y values, they go from 1.2 to 2.3. There's not a lot of distance between 1.2 and 2.3. If I were to go by ones, let's say I went 1 and 2 million and 3 million, everything would be scrunched between like 1 and 2. I mean, it'd be really tiny. It's not even using the whole graph. So let's kind of zoom in on things. I'm going to use the heartbeat, which means I'm going to skip a bunch of values. So I'm going to go ahead and heartbeat, and I'm going to start at 1. And then if I'm only going up to 2.3, maybe I'll use a scale of, well, let's go by 0.2. So I've got 1.2 million, and I've got 1.4 million, 1.6, 1.8 million. There's 2, there's 2.2 million, and now I've got enough space to fit everything on the graph. Again, you could use whatever scale you want. I'm just trying to use my space well and get all the data points on there. So we've got 0, 1.2. 0, I'm over 0, I'm up 1.2, that's going to be right there. 1, 1.3, 1, 1.3, right about there. Over 2, up 1.6. 1.6 is right there. 3, 2.1. Holy cow, so it jumped way up 3 years later. 2.1 is right there. 4 is also 2.1. 5, it dropped a little bit, so we're 5, 1.9. That would have been 2002, which was right after 9/11. So economy was dropping a little bit. People weren't paying as much for advertisements. We've got 6, 2.1. So jump back up. 6, 2.1 is going to be right there. And 7, 2.3. So we'd be up past 2.2, be right about there. It's not perfectly linear. Again, no real-world data rarely is perfectly linear, but we have this general upward trend, which, yeah, would kind of make sense. The more years go by, things get more expensive. So in general, we see that upward trend.